the opportunity, organizers. It's very nice conference, and it is very difficult to handle a session post lunch, that to have a heavy lunch. Okay, let me try to engage. How do we go with? Okay, so the topic stands for adversarial attacks on AI systems. Yeah, the topic itself stands little strange. Okay, we'll see, because in the morning we listened and very nice talk. What is AI, basics of AI, how we go about AI, and what are the advances, because he started from the basics and then covered very nicely the current industrial use cases. So with this introduction, so I am going to start a little bit on the other side. How are we going to leverage this kind of development, AI development? Okay. So before I start, I just want to understand. So how many of you use arithmetics for a calculator, mobile calculator? Everyone, right? So it is maybe now if we find it is 2-digit, now people are started using it. 2-digit arithmetic, addition, multiplication, subtraction we use. Maybe in 10 years of time people may use for 1-digit addition or subtraction, because we rely on the digital gadgets. Similarly, right, how many of us use for the navigation, north, south? So we are very poor in the directions. We use technology to identify whether we are in north direction or south direction. The same thing we use for navigation, to navigating a certain place. So we more rely on the technology, and we more rely on the output it gives, because without sensing. So there are very nice sophistication one can bring into the development of a human being. So then now the technology becomes a culture, right? Because all the essentials what we have, the food and dress, it all become culture. Now the technology also becomes culture. If you go and see in your mobile phone under settings, there is a digital well-being. Under that there is a statistics. So you will come to know that what is the percentage you spend in what apps, right? So that gives how digitally oriented are that. So there are very good things where we can do everything faster and more comfortable way, right? So now we look at the another aspect, because I don't want to give an introduction to AI, because AI everyone knows it is very important, and it's giving a lot of things. Let us understand another perspective. How can I assess these kind of solutions, artificial intelligence solutions? So what are the challenges I may face in these artificial intelligence solutions? Next slide, please. Okay, so now everyone typically knows in any artificial intelligence algorithm, it is basically a computer algorithm which is begins of mathematics, and there is every phase there is an input, training and testing. Okay. So the training phase is what you extract some data and perform the training, and then you extract small percent of data for testing. That is the only thing. But the tests are only to assess the performance. It will not guarantee whether the particular algorithms is working in a right sense or not. Or else how can I verify the outputs it gives is correct? How can I formally verify? Because the testing what you perform is there is a matrix, there is a true positive, false positive. That's accuracy is basically a probability measure, which gives only the efficiency of the algorithm, not a correctness. There is a difference between the correctness and efficiency. Hope you appreciate. The efficiency is just like a part of the data you give and what is an output. But the correctness is like somewhat. Say now take an example. Say now we have a measuring system. So let's take you're going to buy some clothes, right? So that cloth has a measuring system of meter, but that guy says it is in centimeter or millimeter. That he just want to fake you. Then if somebody don't know the measuring system, then he relies on your ChatGPT or whatever app is, right? So how can I believe that whether that gives a correct output or not? So tweaking the data, it makes a impactful and a wrong way of identifying things. So that's where the adversarial attacks on AI is an important thing, and what are the things we are going to measure is in this going to be the talk. Next slide, please. So, this is pretty much about how can we the AI systems are trustworthy and how are we going to leverage and assess these kind of AI system, any machine learning system. Okay. So, this is pretty much about it starts from the life cycle of artificial intelligence system. It starts from the business goals of course, and then you form up the of course, you need a data collection, and then you process the data and select the features and model testing and training. It goes on the flows and understanding the business and keep on learning this. So, this is a whole cycle. It starts from the business goal and try to understand the business and then keep on improving the models. This is completely based on the data. Now, the question is, how can I believe the particular model or algorithms works correctly? Right? Efficiently is another matter, but how can I guarantee that the model, the algorithm that I produce, it's working correctly? So, only assessment we have is data. So, where I know the known data, you just give the known data and then make it a, but the known data is how are we going to classify that it is a correct data? So, in that case, so there are various stages where one is the in machine learning the training stage, another one is the inference stage. The training stage is where you extract lot of features and then you model the system, and the inference stage is what it's testing and infer the sum of the data. As he nicely put it, the data and the data needs to certain treatment, mathematical treatment algorithmically, and then you try to form a pattern. That pattern is used for to understand infer the certain things, hidden things. Okay. So, now the question is, it's everything rely on the data. So, how are we going to assess the data is correct? How are we going to assess the model is correct? Because there are, since the AI systems are now moved to mainline production base and users are started using it, if somebody attacks on the system or model, or the cyber security related issues can bring in a lot of challenges where it can link to. So, how are we going to do that? Okay. So, now just give 4-5 slides of overall taxonomy of AI systems or overall machine learning systems, and then we will move on to the what are the actual threat scenarios where one can this AI could be a failure or we need an improvement. Okay. This is like basically it is it's handling data, right, handling data in a different way. So, if you summarize the data are in form of text, in form of image, in form of audio, that all DSP, digital signal processing, and in form of structured data, right. Structured data is well structured with this. Some unstructured data where you can formulate some of the mathematical models, right. And then if the main domain is either computer vision, it classifies as a computer vision, or it is NLP, because the generative AI more talks about natural language processing a language system, and then speech, and classic data science. Classic data science more deals with the structured data, either it is a empirical data or a categorical data. So, it deals with. So, these are the major data types where any AI algorithms can handle it. Now, the learning part. So, once the data is completed, I have categorized these type of data. Now, I need to fix an algorithm to learn these things. So, these algorithms are divided into 3 categories. One is the supervised learning and unsupervised learning, and then reinforcement learning. So, the supervised learning is what I know the exact classification. So, with that classification I am trying to build up my learning algorithms. So, under that there is a classification and regression. I think the classification is like what it is gives a outcome of either a binaries 1 or 0 or yes or no, and the regression is model where you can use to predict the continuous variable, because it is a difference between a discrete variable and the continuous variable. And then clustering, and these are unsupervised, where I do not know the classification of data set. In that case you just group it, cluster, it is a statistical cluster. And then reinforcement learning is what just rewarding, where once the model is built, it is under the in the production, where you can continuously to learn the new things and adapt the model. So, that reinforce your learnings. So, these are the major categories. So, in generally if you look at the learning algorithms, it is basically a mathematical algorithms or mathematical models which trying to look at the number patterns and form the patterns. Okay. That patterns can be used for predicting future things. Anything in form of either it is a image or video or audio, sorry, it becomes a number pattern. In that number pattern, we are going to form a relationship. So, the learning paradigm, if you look at the overall ML taxonomy, is it starts from the sorry. Yeah. So, I just made it like the data are in this side, and then what is an algorithm, classification algorithm, clustering algorithm, and the reinforcement learning algorithms. So, this class, thank you. So, under this regression algorithms, there is a linear regression, and then there is a new form of things, and then classification we have a support vector machine learning. So, this is a pretty much about the overall ML framework, where it starts from the supervised learning, what are the algorithms, and the unsupervised learning and reinforcement learning. As I said, it is all different mathematical models which can try to form a pattern in a different orienting to certain statistical distributions, wherein if you say a classifier which works on the linear, or classifiers which works on the non-linear, linear classifiers works on the linear relationship in the data, and the non-linear classifiers works on the, you find out the unstructured things, but it generally classifies in the any one of these group. And now people are talking about the deep learning and CNN. These are like an advanced learning methods where they try to look at the data is more abstract. It becomes, say, these models are works data as a number. Now the people are works data as an object, then so that they can collect. So, all the advanced deep learning and advanced things works in more abstract way, so that you can predict more. So, there are 4 important things one should consider before you forming algorithms, because whenever we ask questions or study your research, so you do only the statistical testing. That testing will help you to identify the precision or recall or accuracy, those are measures, statistical measures. So, beyond that, one should look into these 4 factors to assess your machine learning model. Okay. So, that it gives more robust and it is more fair, because we do not know all the statistical outcomes you are trying to bring in the experiments, that all probabilistic. There is no deterministic value. So, your accuracy is probabilistic. When you run a model today, it may give you certain variable tomorrow, and then it changes. So, no one can guarantee that today the accuracy is 98%, what if the algorithm runs on 10 days after? We cannot expect the same accuracy. So, the reason is the fairness component. So, how fair your algorithm is and how robust your algorithm is. So, what if I train with falsified data? So, how robust your model is, and then explainability. So, as he explained in that, say for example, if something is anomaly, so what is the reason behind? So, what is the root cause behind that anomaly? So, explaining the data, and then lineages. It is basically it's an outlier. When I go to deploy in a certain, say for example, a train, say the language model which is built for an English language. Okay. So, can I use a different language to build the system? Say what about Japanese or Chinese or Tamil? So, can the language model NLP which is developed for English, can I use the same model for learning another languages? So, these are like challenges when you identifying these machine learning algorithms. So, let us go by one, because when I say it is a trusted AI algorithms, it should focus on all 4 factors and then give the outcomes. Then only we can say the model is fair and then more suitable for. Okay. The fairness is starts from, it is more of bias to the data. When you use a unbiased data, then you will get a fair model. So, how can I select unbiased data? Because the data comes from some sources, it may be trusted source or untrusted source. For example, let us say take an example when you asking some capital of India in ChatGPT, first time it says Delhi, then there are some planned attackers, they just keep on asking and then they are trying to put it is not a Delhi, it is trying to correct the model. So, over the period of time, if it's 100,000 users, then it becomes Mumbai, right? Because it is learning over the period of time. When you type something and then you intentionally say that your answer is not right, you correct yourself. Then ChatGPT learns a certain period of time, then it changes. It is not only any algorithm, right, when it learns from the nature. So, how can we make a model robust, so that it, even if you give a falsified data, that it gives a fair one. And then security. Now, the people talks about, so there are data which are secure, private in nature. So, your health data, your banking data, or it is a private in nature. So, without disclosing your privacy, how can we perform the analytics about the data, right? Because that is more of robust and the secure model. And then explainability, as I said, say outcome I got, but how can I get that outcome? Say input and training and testing, I got an output from the AI model. So, how can I verify or get an explanation, what is the root cause of that outcome, right? So, that comes from the explainability. And lineages, as I said, when it goes to, when the model evolved for different languages, for a different system, how it evolves. These are the 4 factors one should consider for building a trustworthy AI. Now, we look at, it is more of a cyber security point of view, but the same thing in terms of model efficacy and the performance and the secrecy. So, there are major threats in the AI are at the training stage, and other area in the inference stage. Okay. So, we have 2 phases, as a training phase and the testing phase. The testing phase is called inference stage. So, the major threat which is the attacker, or it is intentionally or unintentionally, okay. There are 2 possibilities, but major vulnerabilities or poisonings are happening in the training stage, because if you train with some mismatched data, okay, a falsified information, then your model may go wrong. So, that is a main part in the, it is called data poisoning attack, where you will train with intentionally or unintentionally train with the mismatched data, and then you try to use that algorithm. And the inference stage, because inference is another important area, when the outcome comes, where try to infer with a mismatched information. For example, the main example is in our polling system, electoral polling. People may give a wrong inference, that may lead to some disturbance in social disturbance. So, in the inference stage also it is very important, it deals with the privacy of the data, and it also deals with the evasion, model evading the model and building your own inferences. So, these are the main 2 stages where the vulnerabilities and threat can be identified. Okay. Now, let us understand very basic level how these manipulations are happening in the training stage as well as the testing stage. So, as I said, everything is going to be a number when it becomes the model is formed. If you go and open the any model, ML model, it is a number pattern, okay. It is a matrix and it is all number patterns. So, the feature itself, whatever the feature you calculate, that feature is a number, right. Either it is a categorical variable 0, 1, or it is some number, statistical number. So, with that you are going to train your model. So, here is a very simple example. There is a image in top, it is a fish image. You just imagine it is a fish image in a binary form, then it has some values, right. If you say consider as a grayscale, it has some numbers, and then you try to add some minor 0.007 in that, and then multiply with your model sign, right. Then it becomes a result like this. It is a manipulated data, manipulated image. With that you get the actual result is there. It's supposed to be a FIS image with 0.9 accuracy. But when you try to manipulate with the data, you are not altering any data, you are just adding some of the invisible things, then you will get a result like more, it looks like a cat or some other object. So, the data is genuine, but people trying to influence with their own inferences, then it becomes the model may go wrong. So, this you cannot, because if you say if I train with 50 original image, 50 manipulated image, right, now you will get a confused outcome. That is what happening even in say people in social network. So, there say people try to text whatever they think. So, majority it becomes true, right. So, how are we going to handle this kind of a data poisoning is what the all adversarial attacks handles. Okay. Let us take some simple scenario how this adversarial is very important, why we need to concern about this. So, first scenarios as I said as a search engine. Search engine is a adaptive model. Based on your search, it is trying to improvise its results in order to provide a more accuracy. But if someone tried to search or damages with a particular company or a particular institution, then it try to adapt that. So, whenever we search, the first data is for we try to get it. So, the company is fraud or they try to give it with some other the falsified information, then the search engine starts to learn. So, that is a major challenge where some search engine try to learn with the falsified information, it may give a false results, that leads to a very dangerous situation. Similarly, for these e-commerce things, right. So, e-commerce say for example, industry wants to buy sell a particular product, they themselves can create an account and then put their positive comments. So, that makes an adaptive falsified information in a particular product. So, that leads to get people attention, right. So, that makes a more of a danger where it comes from the buy and sell e-commerce market. So, another one is the voice systems. These are just example where one say since voice also another bigger challenge, because majority of them voice are mixed, where somebody talks in English or Tamil or many of the languages it may mix up with. So, easily they can hijack with the system. It is all like simple examples where one can easily manipulate the systems over the period of time. Another one is as I said the election results, electoral poll, online polls. A group of motivated hackers or motivated people can change their results over the period of time. So, these are the major adversarial aspect of the learning algorithms, which can really makes a huge difference in the performance as well as the accuracy in terms of security also. This is just an example how this actually this works. Say for 3 different images being trained with the model, and then you induce some of the manipulated images. Now, you look at the outcomes, it is completely a different outcome. This is one of the paper it got published. When you train with it is an image processing example where the DNN is used to deep neural network, and then you try to learn with different images, but the outcomes are, so the car is somewhat a different outcome, and then it capturing as a gene. So, that it is completely different output. So, when you try to misclassify with manipulated images, your inference may go wrong. This is another example where if you just modify with Panda, it is an image processing example where you just manipulate images without changing its appearance, but it still it is showing it the difference. So, if you try to change everything depends on your data. When you try to change the data statistically without altering or tampering much, so it gives a wrong inference. Okay. Now, we look at what are the threat models in this one AI works. One is this timing, another one is the goal oriented attacks, another one is the frequency oriented attack, another one is the knowledge based attack and the falsification. The timing attack is what? It is more of your training period or learning period. So, that is possibility is data poisoning or invading the attack with the new ones. And the goal oriented is more of your outcome or target, where you the targeted changes in your output. And then knowledge based is try to learn the models, because I know this particular algorithm is running on the your system. So, try to learn that algorithm and then do certain manipulate certain things. And then frequency is, so trying to do multiple times, same thing repeating multiple 1000 times, then the model itself can adapt for a falsified information, the frequency attacks. And then falsification, so give the falsified data, that becomes true when over the period of time. So, these are the 5 different attack models where one can damage the AI algorithms. Okay, we will go one by one. I think the data poisoning, as I said, it is very simple at the training space, where you just give a malicious training data, so that the attack model becomes poisoned. Okay. So, it is very simple approach where you train with the mismatched data. And another one is evading attack, where you just still there is a model is produced with the desired outcome, but you try to change with the new samples once the model is built. You are saying even though the training model is producing a right output, but you trying to manipulate the system, no, it is not correct. Then it's try to relearn and then build a remodel, that becomes, so evading the models. So, as I said, when you try to learn these things, where one is the white box attack and other one is the black box attack, where we know what algorithm is used and what data parameters being used, then try to mimic the parameters, that is a white box test attack. Another one is the black box, where you do not know anything about, you try to randomly jump in and then attack. So, these are 2 major attacks where it is a real time attack. There are some things you may know, it is all real time attacks, it is being performed on the live AI systems. So, in that route side I said the data poisoning attack, data itself you poison or logics you can poison. So, there are 2 ways. So, one you poison the data set, another one is poison. So, altering the weights in the neural network, these all can cause us serious damage in overall outcome of this. So, just one slide about how we can formally model and conduct R&D where make a robust model. So, one is to how can we model these adversaries? It is just take an image as an X and then try to model, because image is a matrix which is the numbers, the collection of, it is a function of numbers, right. So, then you just change that function with little delta, just X is a number, then you just add a delta, which makes a huge difference in learning, because everything is a number pattern and then the number pattern may make a different things from the target. So, it is a kind of an optimization people are working, where the number and change a slight delta without tampering. That delta is subject to condition that you will not change much in the X image. Image looks as simple, but there are minimal changes, and then it causes serious damages in this overall system, in the overall target. It is just a mathematical model, it is well known, you can go and explore in the literature. So, as I said, these are the backgrounds where the attackers mainly is thinking is just to do these kind of a distance measures and try to manipulate, either it is output of the outcome of the model, the numbers and the weightages, or in the data side, where one can changes minimal or negligible changes, and then it makes the model more poisoned. So, these are 2 streams people are working, one is on the white box attacks, another one is the black box attack. In white box attack, as I said, there is delta changes, in the X, so that it makes in the series in the white box level. And iterative optimization, as I said, you just process as a frequency, increase the frequency of wrong information, that becomes an white box testing. And the black box testing is like without knowing any model and then try to attack their decisions, say try to manipulate minimal in the decision, that becomes in a white box decision. Another heuristic search. So, it is kind of a brute force attack, randomly giving a different data. Say for example, it is an image processing model. What if you give a text information? Say for example, it is a car, say take a autonomous vehicle, it is a car. So, the driving a car in a surface is different, driving in Chennai, driving in Ooty, and driving in hill station is different. So, if you train with multiple data, then it may cause us, it is a kind of a heuristic search. From that we can understand what are the outcome of the particular model is. So, that is kind of heuristic search without knowing the internals of these things, and we try to model this. So, these are two notions where one can look at in the attacker perspective. So, these are just common attacks which are in the literature. One is the noise attack. Everyone know what is noise. You just create noise in the image or audio or video, so that any of your data, either it is a text data or image data. In my first slide I mentioned the data is in 4 forms, right? Any one of the form, either it is image, audio, structure, video, then you can do introduce some noises. Another one is semantic, that is structural changes in the data. Another one is the fast gradient method. It is basically these are targeted attack. Iterative method, gradient methods are you changing in the learning space, where the when the learning algorithms try to manipulate in their functions, that these 3 attacks. And deep full attack is what it is specific to the deep neural network, DNN. In that you just try to change the attacking neurons. So, that is a deep full attack. And this Carney-Weger attack is what it is more of output and input correlation. So, you just try to map with some irrelevant input. So, that becomes these attacks. So, these are common adversarial attacks available. One can search and verify your data, whether the attacks are robust, your model is robust or not. So, let us now work out what is a countermeasures, what is a solution for this kind of attack, how can we face these attacks. One is the reactive measure, another one is a proactive measure. So, in the reactive measure, where the model is attacked, how are we going to leverage? So, there are 3 aspects. One is the adversarial detection. If somebody tried to changes your model, then you should know that somebody is mimicking your thing or somebody is wrongly providing input. So, the adversarial detection and then input reconstruction. Says you may feed with a poisonous data, but the model itself clever enough to understand and remove that noises and then try to learn it. And then network verification, where it is in a model, every time I formally verify the learning algorithms performs well. So, these are like reactive measures, and the proactive measures are network distillation, because the neuron model is a network where you do distill every time. If any noises or misinformation, you try to eliminate it. And then adversarial retraining. So, your model should be well robust to retrain and then build original things. And then robustifying. Robust is, as I said, it is you can provide a falsified information, the model itself reconstruct and build a new classifier. So, these are 2 notions where the reactive and proactive measures we can protect the AI systems. So, some security controls, one is the building explainable AI. Explainable AI is it is not it is a white box where you can explain everything, all the logics, and then implement the process. So, the process needs to be implemented, sanitize your data, and then implement the tools, data points, where you just sanitize your model every time when you go for production, and integrate with the model evaluation tool. The evaluation is not only performance, it should be identified whether your model is correct or not. Formally, it should be verified, and then reduce the information available. Publicly, you should not disclose what model is being used for a particular algorithm. So, these will help as a security controls, because you see we are facing lot of AI systems. If something goes wrong, then it is even take an autonomous vehicle. Somebody try to attack that vehicle, it's a serious damage. Now the robots are using everywhere in industrial systems. Somebody try to hack that it's going to be a serious damage. So one should look at all these measures and then build a robust and very secure solution. Okay. This is just a role, how are we categorizing these things. One is there are many roles, because AI is as a data engineer who is responsible for preparing the data, and data scientist analyzing the data, and engineer, ML engineer is the one works on the creating algorithm, and then business analyst who are in the domain expert. So everyone should take a role and then make it as a more robust system. Okay. To summarize, I think there is no so far there is no solution, universal solution where we can prevent these attacks. So one can focus in R&D problem, how are we going generate a model which can sustain for any type of attacks. And another one is the identifying the threats and the security gaps. As I said, so there are many machine learning algorithms dealing with confidential and secret and privacy data. So without disclosing this information, how can I build a very secure and privacy related things, and then enhance the cyber security posture, because what if somebody intruder tried to get into your system and manipulate your model. So that, and then carefully investigate the parameters which are being set up in the model, keep it in confidential. And then finally, there are a lot of open problems, research problems in this area one can look at, because the typical way of advancement in AI is going on. So we have deep learning and CNN and there are many things, but very few people concentrate on how can we work on the correctness of this model. So these are the some of the areas one can look at in the cyber security point of view, as well as the AI point of advancement in AI. So with this I conclude. Thank you very much. Any questions I am happy to. Yes, sir. Yes, sir. You are audible. So database bias is basically it's a data collection point of view. So there is no such tools. How can I verify that? It is a question of trusting the data, trustworthiness, the trusting the data. So there is no point to trust the people, who collect the data. So, yeah. According to the statistical treatment, where you can apply some of the statistical measures, that data is regular or not. But that your question is more of trustworthiness, where who is providing the data, whether an authorized or trusted person is providing the data, or some random data which was in the lab. That's good. Yes. There is no mathematical or a machine learning treatment one can verify whether the data is trustworthy or not. Yeah, that is more of privacy related things. Say for example, if you use your private data, as Morning mentioned, asking a PII information, personally identifiable information. There are category of information, your age, your sex, your date of birth. There are personally identifiable information that can be easily handled. So there is a method called homomorphic encryption, where you do just encrypt all PII information. Still it is secure, you can disclose in public. But in case of those models like deep learning models, it is very difficult to find out which are the significant features and insignificant features. Sir, significant features like black box. Yes, sir. So actually playing the role in the final decision. Okay. Correct. So there are techniques where, for example, in a dimensionality reduction, they called principal scientific component analysis or PCA-IC. There are statistical techniques, but as a model, because the advanced model like DNN or CNN, it handles data as an object. It is never talks about the number characteristic of a data. So, all the data is a graph. They are trying to form a relation between graphic relationship, more abstract way of handling. So, it is very difficult to identify which data, because as a human we try to extract feature, that feature is according to our knowledge. So, somebody writes a code for a feature extraction, that is his understanding. But in advanced machine learning algorithms, not rely on the features, it just accept the object and then try to manipulate, infer its own. So, that is the difference. Yeah, yes ma'am, please.
Ma'am, yes, you.
Sir, your question is more about how features are related to your final decisions or final prediction kind of thing. So, there are a lot of correlation techniques available. So, with that you will be able to correlate whether the features is correlated for the predicted target value. Statistical algorithm.
Model.
Yes, so for deep learning, so you can correlate it, and if they are correlated, because for deep learning model there is no need of any filtering kind of things. So automatically it will consider all. So in normal neural network model we start to learn the weights alone. Here we are not going to learn the weights alone. So even the filters also we are going to learn out of that. So we are just going to feed the data to the model so that it will automatically check all possibilities. If there is any relevancy, it will take it, otherwise it will just ignore it, that's it. Right? In the statistical case, we'll take the correlation analysis. For a deep learning model, there is no specific filtering kind of things available. Thank you.
Sir, last question. Nice presentation, scientist sir. You have discussed about the minimization problem, right? Is it a constrained or unconstrained optimization? If it is constrained, you have not mentioned about the non-negativity vectors. I would like to know about what are the factors for minimization.
Okay. So, the constraint and unconstrained come to subject to the variable, the problem. So, I just took for an example for understanding, it is an image processing problem, where it is say what are the parameters, it is a intensity of the image or the correlation of image. These are constraints, because intensity has a boundary where it is all constraint variable. It's subject to the model that you create. So, either it can be constrained environment where you know
no problem, that is another angle. In minimization, what are the KPI, influencing factors for minimization? For example, time minimization, effort minimization, stress deflection, varying capability, space wastage, all are under the kind of minimization. So, for understanding purpose, you have discussed. Give the two factors. Please, can you mention two factors?
Sorry, I didn't.
Then only in feasible region it occurs. If it satisfies the feasible, it goes to optimize the optimization split which satisfy the objective function.
Correct.
Is
so
it?
The objective is, say I have a original image, I have a manipulated image. The objective is to minimize the difference.
If you have mentioned the H, delta H. If delta H varies, what is global problem, minimum problem? Among all the problem, in minimization, global minimum is the optimization.
Correct.
Like that, what factors?
So here, as I consider is X is an intensity, because the image intensity, it's the only factor. But it is, you no need to restrict. It's just a simple mathematical model for a understanding. One can model image in a different way. Say if you apply a transformation, FFT or DFT, it becomes another domain where you get a multiple factors. So it is up to your modeling, how you model the problem, and then subject to the parameters you choose for optimization.
Nice, sir.
Thank you. Yes, yes, sir. Yes. Yes.
Suppose most of the time we are using with benchmark data for all kind of applications, whether it's data processing, image processing, or data security, or anything. We are working with only the benchmark data.
Yes,
so all these benchmark data are tested, and it is reliable one.
Right.
So how that poisoning data might be there in the data set?
Okay, sir.
Because mostly we are trained with
I think
data.
it's a follow-up question. Say where if you collect the data in a trusted source, because it is benchmark data. Say there is a NIST data set. There are some data set you collected. It is all considered to be a trusted ones. So no question of it. So there is a data set available in GitHub. So somebody put intentionally with a falsified information. It is an untrusted source of it. So in that case, how are you going to analyze the data? Is adversarial attack, sir. So it is an unclassified data, or the data which received from is an untrusted sources.
So being a end user, how we can predict that one? Because
that's a question. Yes, sir. So there is no, to my knowledge, there is no statistical test or a mathematical treatment one can differentiate trust. It's question of trustworthiness. But only by analyzing the actuals and then what is a factual, then make it bigger. But there is no treatment, at least to my knowledge, how can we differentiate?
just a curiosity I'm asking about, because we are working with cup data, all these data.
Yeah.
All the data are benchmark data. We don't know any find about that.
Correct.
But instantly when you say about that,
Yeah,
I came to
it's up to our observers, sir. Even if you say population statistics, there are people taking population statistics based on their understanding. They're just querying it.
just like YouTube,
Yeah,
whatever
it is an observer. If observer is trustworthy, then the data is considered to be a trusted one.
just like social media nowadays, everybody is posting
Yeah,
their own
then
views.
we cannot.
Okay, thank you.
Thank you, sir.